determine the proper size bonding jumper for a steel structure, such as a steel vessel without electrical devices, in an industrial plant with an underground grid system. Firstly, determine the maximum fault current that could flow through the bonding jumper. This can be calculated using the formula maximum fault current equals line voltage divided by ground fault impedance. Line voltage refers to the voltage level of the electrical system. Ground fault impedance represents the impedance between the point of fault and the grounding system. The ground fault impedance can be estimated. For an isolated ground system, use 25 ohms. For a solidly grounded system, use 1 ohm. Secondly, once the maximum fault current is known, use table 250.122 to select the minimum size grounding conductor. To do this, 1. Determine the ampacity of the bonding jumper. This is equal to the maximum fault current. 2. Locate the equipment grounding conductor column in table 250.122. 3. Select the conductor size that has an ampacity equal to or greater than the calculated ampacity. For steel structures, you can also use a rule of thumb. For steel structures less than 250 feet long, use a copper bonding jumper with a minimum size of number 6 AWG. For steel structures 250 feet long or greater, use a copper bonding jumper with a minimum size of number 4 AWG. Once the bonding jumper size is determined, connect it to the underground grid system. 1. Locate an accessible point on the underground grid system. 2. Drill a hole in the grid system and insert a ground rod. 3. Attach the bonding jumper to the ground rod using a corrosion-resistant clamp to ensure a reliable connection and prevent the bonding jumper from deteriorating over time.